done with that. We're inside the operating system. We're running in privileged mode. We're off doing what we want to do, which is run our, pardon my French, badass OS code. Okay? It's just who we are. We are XV6. We rule. Now, we have things outside the kernel because we need to have the ability for someone to enter commands to test our operating system. Right? And we're going to see in a minute how that works. But the first thing that happens when we boot our system is we create a process called init, I-N-I-T. Init's job in XV6 is to initialize the very first CPU. Okay? There's more than one CPU in XV6. We're currently using 6. We've tested it with up to 7. Theoretically, we could use 31, but we've never had it stay up and be stable for very long. As I said, it's a teaching operating system. It's not commercial grade, even though they used to sell it to people. Snake oil comes to mind. So keep the number. It's called NCPU, all capital. Just keep that number at 2. Right? For testing purposes, for debugging, you might have to change it to 1 periodically, but we will always run your code with it set to 2. All right? And that's for some concurrency things that we need to see. We'll see later on. All right, so you just want to see how this thing works? Okay. How many of you use make? How many of you have used 343 line make file? This is our make file. There is a lot of stuff in this make file. And as far as make files go, it's essentially fairly simple. Okay? Now, the way it comes from MIT, you have to go through and figure out this make file. So you can figure out where to make changes. We felt that the class and operating system should not be a class in learning how to program the make system. We just think that that's a skill that it's specialized in the industry. People who write compilation scripts, they're hired as contractors. They get paid $300 an hour. They come in, work for 3 days, and then they leave and go to another company and get $300 an hour. It's specialized knowledge. So instead, we set it up so you only modify the top part of this make file. Okay? So everything at the top here, down through this comment, is stuff that we put in here, and this is the only part of the make file you will have to change. Okay? That gets us somewhere around 40 lines or something like that. So the way it's going to work is the following. When we give this to you, we set the project flag, CS333-project, we set the value equal to 0. And what that means is compile it without any student code turned on, which you'll have to do for all your testing. So this means that you can have no code outside of your conditionally compiled directives. It will all be conditionally compiled. And this is a way for us to quickly tell if you send us your code saying, I have a bug, and if we turn the flag off, set it back to 0, and all of a sudden it still doesn't work, we know that you've made a mistake someplace else. Either, had to have been outside of one of the pound defines. Sometimes, has anyone ever inadvertently hit the keyboard when they were in VI and had it scramble your file on you? Source code control. Okay, it can be very painful. Suddenly you go like, it says there's a change in this file, and I didn't change that file. Okay, the L's did. Okay, but it happened, and it happened to your file, so we're going to blame you for it. Or actually, you're going to fix it. All right? So be very, very careful. So for the first project, we'll change that to 1. Then we have a flag called print_syscalls. And in the first project, you're going to set it up so that system call traces are printed. So every time a system call is invoked, it'll say, hey, this system call was called. And that does two things for us. Is one, sometimes you need to know whether or not a system call was invoked. Remember how I said you could inadvertently give the same system call to different members? That's how you would figure it out. You go, oh, I'm making this system call, and it says, no, you gave me a different system call. I'm calling my system call, and you told me I was calling date. Okay, it never got to my system call, so that's not where my bug is. Let's go figure out what's going on. So we'll turn that on from project 1. After project 1, you're going to turn it off and never turn it back on unless you have some kind of weird bug. Okay, but we'll want to maintain that. We'll see that in project 1. We have a flag out there called PDX_XV6. All right, and those are the changes we've made against the MIT distribution. Do not change those at all. Do not put any code into that conditional compilation blocks. Those are there for very specific reasons to overcome features of the MIT operating system. Okay. We've been slowly getting them to put our fixes back into the main branch of the operating system, but they seem to be putting in bugs faster than we can get them out. But there's some things that we do that are specific to us. And that -D, has anyone ever used the -D when compiling a program, -D? That's the same as doing a #define, except it defines it for every file. So instead of putting a #define someplace for PDX_XV6, I just put it on the compilation line, and it's defined for every file. So it's where I need it. So it's a system-wide define. Okay. And you'll be doing some of that down here. We'll see it when we get down below. And then, see the very next line, we say, this is now Makefile Programming 101. We're doing an if statement. We're saying if the flag CS333-C flags is equal to -D PDX_XV6, which we know it is, we just did the line before. It says set the flag CS333-UPROGS, which stands for user programs, to be whatever it was plus _halt. So XV6 did not come with a command to shut down the operating system. Isn't that fun? Okay, we had to crash it in order to get it shut down, which leads to some of the annoying hangs and things like that. So we wrote a halt command, and we put it in there. And because it's not part of the original Makefile, we stuck it up here in the 333 part. And then that's the end of our if. The next one says, is print syscalls 0 for these flags, 0 is off, 1 is on. If print syscalls is on, to our C flags. You guys remember C flags? Yes, our compilation flags for C. We have the ones for our class are called CS333-C flags. And we'll see later where we add our compilation flags to the rest of the compilation flags for the system later on. Okay? And then we just say, define that symbol. And so then it's turned on. So when you guys put the code in for printing syscalls, you just say #if_def print_syscalls, then do the code for printing the syscalls. For project 1, if project 1 is defined, we're going to set the compilation flags to define CS333_P1. All your code will be conditionally compiled. You may have no code outside of conditional compilation, so we can turn it off to help debug. All projects will build on previous projects. So for example, down here when we do project 2, the first thing I do is define CS333_P1. So P2 will use all the code for P1 automatically. P3 will use all the code for P2 and P1. P4 will use all the code for P3, P2, and P1. Okay? Just how it's going to work. If you're working on project 3 and all of a sudden you find a bug, one of the first questions you want to ask yourself is it a new bug with project 3, or did I just finally get around to finding a bug from project 2? By setting the flag back to 2, you can figure that out. Think about that. These are really cool tricks in development. We also have user program, uprods, user programs. A user program is something you type at the shell script, at the shell prompt, the $sign prompt. ls is a user program. So it'd be a uprod. And we'll be writing test programs. Okay, we give you a date command, a date program to compile and put into your system. But in project 2, you'd be writing your own. You'd be writing other ones. And so we'll be putting them down here. And then when we have test programs, we separate them out into uprods and tprods, which are they're both of them. Both of these are things you can type at the shell prompt. It's just that we want you to tell us which ones are just there for testing. Because if they're just there for testing purposes, like you wrote a specialized test program, and you know, we look at it and we're like, well, but I'm not going to run your program. I'll just comment it out. Okay. But the required ones, we can look at the required ones. We know exactly what those lines should be. Now, a weird thing about how this makefile works. You ever worked with that one person that has really, really good intentions, but winds up doing stuff that, while laudable, seemed like a really good idea? You just want to pat him on the head, give him a cookie, and tell him to sit in the corner? In our makefile, all of our user programs, like ls is a user program, but to the makefile, we have to say it's called _ls. And that's just because of the way they wrote the operating system. I was like, well, why did you guys do it? And I got back an email that said, it seemed like a good idea at the time, right? It's like, yeah, been there, done that. Okay? So, but by the time they got around to going like, we don't need to do that, we don't need to somehow specially identify them, they'd already written it into too much of the operating system and the build environment. So it was just like, it's great. You ever do that? Just like, it works. This is one of those things. Not a real great idea, but it's not a bad idea either. So this _date, when I boot the system, there will be no command called _date. When I boot the system, it will be called date. Okay? And that can be very confusing the first time you look at it. Right? So we'll take a look at that. So what I want to do now